True, ma what is time? Is it a constant flow, ticking away from the past into the future? Or is it something far more mysterious, perhaps even an illusion? At first glance, time seems simple. We experience it every moment. We measure it with clocks. We age. We plan. We remember. Time feels like the backdrop of our lives, moving in one direction, forward. But when we look deeper, especially through the lens of physics, our intuitive understanding of time begins to fall apart. Einstein's theory of relativity revolutionized our perception of time. According to general relativity, time is not an absolute universal flow that ticks the same for everyone. Instead, it is relative. It can stretch and compress depending on your speed and the strength of gravity around you. This means that two observers moving at different speeds or experiencing different gravitational forces will measure the passage of time differently. A clock on Earth ticks at a slightly different rate than one on a satellite in orbit. This is not just theory. It's a real effect we have to correct for in GPS satellites. Time, it turns out, is a dimension, much like space. Together, they form what we call space-time. And in this four-dimensional fabric, the future, present, and past may all coexist, just like all locations in space exist at once. So, if time is a dimension, does that mean the future is already there? Are we simply experiencing one slice of the temporal loaf at a time? This idea is known as the block universe theory, where the universe is like a frozen 4D structure, and the passage of time is just an illusion born from our consciousness moving through it. But then, why do we experience time as flowing? Why do we remember the past, but not the future? This brings us to the concept of entropy, the measure of disorder. According to the second law of thermodynamics, entropy tends to increase over time. This increase gives time its apparent direction, what physicists call the arrow of time. In a low entropy state, like the early universe, structures and patterns were simple and organized. As time progresses, systems move toward higher entropy, toward disorder. Ice melts, eggs break, stars burn out. These processes are irreversible and help define the flow of time. But here's the twist. The laws of physics are time-symmetric. They don't distinguish between past and future. So why does time have a preferred direction for us? Some scientists suggest that the arrow of time is tied to the initial conditions of the universe. The Big Bang began in a state of extraordinarily low entropy. From that moment, entropy could only increase. If the universe had begun in a high entropy state, the arrow of time might not exist, or might point in a different direction. Others wonder if time is even fundamental at all. In certain approaches to quantum gravity, like loop quantum gravity, time does not appear as a basic ingredient. Instead, it may be an emergent property, arising only when many particles interact. In these models, time is not a thread running through the fabric of reality, but a statistical byproduct of more fundamental processes. It would be like temperature, something that emerges from the collective behavior of molecules, not something that exists on its own. This opens up wild possibilities. If time is emergent, then perhaps in some corners of the universe, or in other universes entirely, time as we know it does not exist. What would existence be like without time? Could consciousness still arise? And what about time travel? If the block universe is correct, and all moments in time exist simultaneously, then traveling through time might be as natural as traveling through space. But paradoxes arise. Can you change the past? Could you meet your future self? Some solutions come from Einstein's equations themselves, such as wormholes or closed time-like curves. These hypothetical constructs would allow paths through space-time that loop back on themselves. In theory, they permit time travel. In practice, they remain speculative, and no evidence of such structures has yet been found. Quantum mechanics adds yet another layer of mystery. In the quantum world, particles don't evolve smoothly over time, but exist in a superposition of states until observed. Some interpretations, like the transactional interpretation, suggest that events in the future can influence the past, creating a kind of retrocausality. If true, our notion of time as a one-way street would need a major overhaul. At Infinity Beyond, we ponder not just what time is, but how it defines us. We are time-bound beings. Our thoughts, decisions, hopes, and regrets are all woven into the fabric of time. And yet, the more we study it, the more it seems like a construct, a phenomenon that arises from deeper rules we don't yet fully understand. Time affects everything, from how we perceive the cosmos to how we experience love, loss, growth, and death. Without time, there would be no stories, no change, no history. But perhaps, in some higher realm, all stories are already written, and all moments already exist, waiting to be experienced. In our next episode, we'll move from time to structure, investigating how matter clumped into stars, galaxies, and the vast cosmic web that stretches across the universe. If you've ever wondered what time truly is, and whether it's real, you're not alone. Subscribe to Infinity Beyond, and let's continue questioning everything. Ta biết ngày nay bắt đầu từ một khoảnh khắc kỳ diệu, một vụ nổ vũ trụ rực rỡ từ khoảng không vô tận, mở ra không gian, thời gian và mọi vật chất. Từ bóng tối tuyệt đối, ánh sáng đầu tiên lóe lên, những hạt vật chất sơ khai hòa quyện, tạo nên các ngôi sao, thiên hà và hành tinh. Đó là khởi nguồn của tất cả, nơi vô hạn vượt xa mọi giới hạn, dẫn dắt nhân loại khám phá bí ẩn của sự tồn tại.